Hi, I'm Lucas Canton. I teach a lot of intro chemistry at Cabrillo College, and I want to tell you a little bit about my career path. I got my undergraduate degree in biochemistry and molecular biology. Then I worked in several careers for 1 to 2 years in each career. And I don't recommend this, but what I saw was that with a chemistry background, there are a lot of careers that you can do. Let me tell you about a few that I did in my career path. So one of my first jobs out of my undergraduate program was working at Cytoculture, where we did contract bioremediation studies. There we would determine if microbes were essentially eating an oil or gas spill. We're trying to determine how long it would take for that gas spill to get completely eaten up by these microbes so that it was no longer a threat to whatever. In this picture, this is showing a worker working in a glove box that has no oxygen in it. In this environment, these special microbes can grow and eat oil. So I'd basically make petri dishes that had diesel fuel as a food source. We would grow these microbes from samples given to us by different spill sites. Then I went to work for Dexter Aerospace. There I did research into new plastics for aerospace. The aerospace, meaning planes and jets and these kinds of rockets, use actually a ton of plastic, believe it or not. Actually, the main structural component of planes is plastic. This is showing where the plastic gets cooked in gigantic ovens, and then they basically bolt these large pieces of plastic together. So the metal on the plane is just some flashing on the outside, but really the thing that holds your plane together is plastic. And so I don't know if you've ever flown in a jet, but the wings will kind of sway and bounce because there's some flexibility, and that's actually important. You don't want your wings to break while you're in flight. Okay, then I went to Romic Environmental, and there I worked as a field chemist packing up old chemicals and chemical waste. This was really important to me. I actually studied some environmental issues for a year before I actually settled on my biochemistry major. To me, this ensured that the chemicals didn't end up in the environment. I had seen where companies like IBM actually dumped solvents into the ground just to get rid of them because it's actually quite expensive. And we would pack this up and prevent this. Also at Romic Environmental, I didn't do this, but I thought this would be interesting to you. For really large scale chemical waste, we're talking tens of thousands of gallons and perhaps more, just lots and lots of truckloads of chemical waste. They'd actually boil them in what they call fractional distillation columns. And so what this would do is it would separate the chemicals from the mixture of the waste stream. And so they could recover alcohol and methanol and whatever was in the waste stream. And then those chemicals could be reused again. This is really similar to how they process crude oil. So then I went to work for Applied Biosystems. And they actually make research equipment for other biotech companies, which is really fascinating. This picture is showing a PCR, which actually makes copies of DNA. What I did is I worked on research to develop what they call a gene chip, or also technically called a microarray. It performs 100,000 tests at once and can analyze your DNA looking for genetic defects and all kinds of things. So they use it in the medical industry all the time nowadays. Genetics is becoming a larger component of doctors and medicine, but it's also used for research as well. Okay, so I took a hiatus and then I worked as a lab technician at another community college where I would prepare reagents for instructional chemistry labs. And I wasn't that excited about this job. It was okay. I think actually my biotech job was more interesting. But what I found was I saw students in the classrooms getting really excited about learning. And so what I decided to do was go back and get a graduate degree and teach chemistry. That's what was really interesting to me. I witnessed the chemical demos of other teachers. Here's one of mine. Oh my God. Okay, so that proved it's methane. And then you see the density. So this is showing that the methane in the bubbles is less dense than the air and essentially rises. We ignite it to prove that it's not some rogue air that's somehow violating the laws of physics. The chemistry demos are very exciting and make chemistry really come alive for my student. I don't want to give you the impression that we just burn stuff though. We do lots of other chemical demonstrations that demonstrate a lot of the core principles of chemistry. Okay. That was actually burning stuff. No, actually, it's actually showing chemistry at the same time. Essentially, the thermal energy in the methane is less than the energy required to take the water that's in the bubbles from the liquid state to the gas state. And hence, my hand didn't get burned at all. No, but really, there are other demos that show other principles of chemistry, such as gas laws and whatnot. I just got those because students filming me get more excited when the teacher's in danger. But my colleagues will show some of those in the other videos that will follow. Let's look at it one more just for fun. I'm going to pee my pants. Ooh. Oh, look at that. Okay, now I admit it. That time we were burning stuff. But that's a combustion reaction. That's what chemistry is about. After all, you have to get that air and fuel mixture just right. You know, if we study a chemistry class, that's what you will study. And this demonstration helps us understand the basic kinds of chemical reactions. In teaching chemistry, I found a career that I really love. I think it's really critical for the students to get a foundation in the core principles of chemistry. In Chem 3, we give the students a break and they have some time to focus on these core principles, balancing equations, stoichiometry. In Chem 1A, it's going to go a little faster. It's going to be a little bit more complicated. But I really enjoy seeing the students learn this stuff and get really excited about chemistry. That's what makes it really exciting for me. I hope I've showed here that there are a whole bunch of careers you can do in chemistry. With a good foundation in chemistry, you have a lot of exciting possibilities awaiting you. Good luck.